Welcome to Your Math Explained, where we make math simple and clear. My name's Angela. Up until now in algebra, you've mostly worked with straight lines in the form of y is equal to mx plus b. You move a step forward, you rise a steady amount. It's clean and it's straight. But the real world doesn't move in a straight line. Think about a thrown basketball arc. That curve is called a parabola. Parabolas are governed by quadratic equations. Today, we're investigating the general form of a quadratic function, discovering why its graph curves using a table of values, and building an algebraic formula to locate its exact turning point symmetry. Now, before we jump in, if you haven't subscribed to the channel yet, make sure you do that first so you don't miss out on new weekly content. Let's take a look at the basic general form y is equal to x squared minus 2x minus 3. We're going to create a table of values and sketch the graph. So that means we would have our x value, and then we would have our y value, which is equal to x squared minus 2x minus 3. So then the coordinates would be x, comma, y. So for x value, we get to choose what we want to input. And here we're going to choose -1, 0, 1, 2, and 3. And then based on these x values, we're going to substitute into our equation for y, and then we're going to find our y values. So if x is equal to -1, then y is going to be -1 squared minus 2 times -1 minus 3, which is equal to 0. So our first point here would be -1, comma, 0. When x is equal to 0, we get 0 squared minus 2 times 0 minus 3. So that would be -3. So our second point here would be 0, comma, -3. And repeating the same process for the next three x values. So we get 1 squared minus 2 times 1 minus 3, which is equal to -4. And that gives us the point 1, comma, -4. 2 squared minus 2 times 2 minus 3 is equal to -3. So we get 2, comma, -3. And then the last x value is going to give us 3 squared minus 2 times 3 minus 3, which is equal to 0. So then the last point would be 3, comma, 0. So then if we were to sketch this by plotting those points that we got, our first point would be -1, comma, 0, so that would be right over here. Our second point is 0, -3, so that would be right over here. 1, -4, 2, comma, -3, and then 3, comma, 0. So looking at the y values here, we notice something unique. They don't grow at a constant rate. They drop down to a minimum and then mirror themselves up back again. So the shape of this graph would actually resemble something like this. And this is what we call a parabola. So the general form of a quadratic equation is y is equal to a times x squared plus bx plus c, where a, b, and c are constants. The value of a determines the orientation and the scale. So if a is greater than 0, then the parabola is going to open upwards and it'll have a minimum value. But if a is less than 0, then the parabola is going to open downwards and it's going to have a maximum value. And that minimum or maximum is what we call the vertex. The value of c is the y-intercept, because if you substitute in x is equal to 0, this is going to be 0, 0, which means you end up with y is equal to c. The middle point of the parabola is called the vertex, because that's where the minimum or the maximum occurs. And because parabolas are perfectly symmetrical, we can locate their central mirror line, which is called the axis of symmetry, using this formula here. So now with this information, let's take a look at our next example. We want to find the equation of the axis of symmetry and the coordinates of the vertex of this quadratic equation here. So writing down our constants, we get a is equal to 2, b here is equal to -8, and c is equal to 5. Now the equation for the axis of symmetry is x is equal to -b over 2a. So that means we get this is -8 over 2 times 2. So our axis of symmetry here is going to be x is equal to 2. And remember, the axis of symmetry is always an equation, so you have to give it in the form of x is equal to something. So make sure you write down x is equal to 2 instead of just 2. Now that we know the axis of symmetry, we can go ahead and find the coordinates of the vertex, because the vertex always occurs on the axis of symmetry. So that means we know for our vertex, we're going to have an x value of 2. And now we just need to substitute in this x value to find our y value. So we get y is equal to 2 times 2 squared minus 8 times 2 plus 5. And that is going to give us a y value of -3. So therefore, the vertex is at 2, -3. And now let's do a quick recap of what we covered in this video. We learned that the general form of a quadratic equation is in the form ax squared plus bx plus c, where c is the y-intercept, and a controls whether the curve is an upward-facing cup or downward-facing cup. It also controls the steepness of that cup. We also learned that parabolas are symmetrical on the left and right, and that line straight down the middle is called the axis of symmetry, and we can find it using the formula x is equal to -b over 2a. And once we find that axis of symmetry, we can use that x value to find the coordinates of the vertex, because the vertex always occurs on that axis of symmetry. And lastly, different textbooks can have different naming conventions. We use the general form as a name for the form ax squared plus bx plus c, but it can go by different names in different textbooks. So don't be surprised if your book calls it something else. And now it is your turn to give this a try. Can you find the solution to the problem on the screen here? Make sure to leave your answer in the comments below and let us know what other quadratics topics you'd like to see in the future.
That's it for this video. If you found it helpful, remember to hit that like and subscribe. And if there's a topic you'd like us to cover, make sure to drop it in the comments.